Hello friends, welcome back. In this session, let's try to understand about sandwich theorem with respect to limits by using a simple example. So for that we will take this example. We have been asked to evaluate limit of function x square into cos 2 by x as x tends to 0. So this is what we have to find out the limit. So we'll be using sandwich theorem and we'll try to understand what is sandwich theorem, in which scenarios we can use this sandwich theorem. Before that, let's try to see how much we can go ahead with this particular problem. So since I see a trigonometric function and I know that cos and sine always lie between -1 and 1, is it safe if I say -1 less than or equal to cos 2 by x less than or equal to 1? So we are saying that cos function value should be between -1 and 1. For any sine function or cos function, you know that the range is -1 and 1. That means the all values should be between -1 and 1. Now I see here x square. So what I will do, I will say multiply with throughout x square. I will have minus x square less than or equal to x square cos 2 by x less than or equal to 1. Okay, less than or equal to x square. So if I write x square there, okay, right. Now suppose we apply limit on this, it will become limit x tends to 0 minus x square is nothing but equal to 0. That is also equal to limit of x tends to 0 x square. Now you can see that the limits at the extremes, they both are tending towards 0. The limit value is 0. So at that time I can go ahead and say the function which is in between, that is nothing but x square cos 2 by x, that also has a limit and the value is nothing but equal to 0. So what we are saying, let me repeat that. We know that cos, we are trying to solve this. So we are saying cos function values, or for that matter sine or cos, the range is -1 to 1. So we are saying -1 less than or equal to cos 2 by x less than or equal to 1. So now I see in the problem we have to multiply with x square. So I multiply. I will have minus of x square less than or equal to x square cos 2x less than or equal to x square. Now I see that limit x tends to 0, minus x square equal to minus 0 square, that's nothing but equal to 0. And also I see that x square is also tending towards 0. Now by sandwich theorem I can say that if x square and minus x square are having a limit of 0 as x tends to 0, then x square cos 2 by x also should have limit of 0. Now how this works out? Let's have a look at this by graph so that we can understand it. Before that, let's go and understand what's the definition of sandwich theorem. Here we go. Sandwich theorem says, let E be subset of R, f, g, h be functions mapped from E to R, and let A belongs to R such that A minus R, A plus R open interval other than A intersection E is non-empty for every R greater than 0. If you read this all, nothing but we are saying in the deleted neighborhood of A, so and E and that there are saying that there is no difference between them. That means there is no non-intersection points. Intersection is phi. That means there is no difference. Okay. If f of x is less than or equal to g of x less than or equal to h of x for all x belongs to E, and if limit x tends to a f of x equal to L, that is also equal to limit x tends to a f of h of x, then limit extends to a, g of x exists and it is equal to L. I'll repeat that again. We have taken E as a subset of R. E is an open interval on R. We have three functions mapping from E to R, and we are taking a value, a belongs to R, such that we are talking about a simply deleted neighborhood of A, and we are saying if f of x is less than or equal to g of x less than or equal to h of x for all values of x which are part of E, that means between a minus R to a plus R other than A, and if f of x and h of x are as x tending to A, both of them have limit value equal to L, then g of x also will have limit as x tends to A, and that is nothing but equal to L. So let's try to understand this with the help of a graph. Let's look at the graph here. We have been told that, if you remember, we have to find out the limit as x tends to 0, x square cos 2 by x. For that, what I will do, I have told you that cos of 2 by x should be between minus 1 and 1. So let us first plot minus 1, and let us also plot 1. So you can see that I have minus 1 and 1. I'll just maximize it so that you can see it clearly. You can see there I have minus 1 and 1. Now if I introduce here cos of 2 by x, whatever may be the values, all those values should be between minus 1 and 1. So let's have a look at that. So now you can see, so interesting, you can see that all the values of cos 2 by x are between minus 1 and 1. And you can also see that for any value the range of cos function is minus 1 to 1, which is also satisfied here. Now we have to find out x square. So I will go ahead and say here minus x square. So the minus 1 will become a parabola now. Similarly, I will go ahead and convert 1 into another parabola. That's nothing but I have to multiply with x square. So I will multiply with x square. I will have the parabola. You can see that minus x square is opening down and x square is opening up. Okay, right. Now let me multiply cos 2 by x also with x square, and let us see how sandwich theorem works out here. I am just trying to multiply x square cos 2 by x with x square. Now you can see that that's a beauty. I hope you will appreciate that. That's very, very interesting. If you are able to maximize this, zoom this a little bit and see, you can see here now what are our two functions. Let us talk about them now. What are our two functions? One is minus x square, that is nothing but given by the parabola which is opening down, and another is x square which is opening up, and in between we have x square into cos 2 by x. Now suppose I say minus x square is f of x, and minus x square into cos 2 by x is g of x, and x square is h of x. You can see that for all values of x belonging to, let us say something like, we are talking about a is maybe something like up to minus 1 to 1, let us say a minus r to a plus r is nothing but minus 1 to 1. You can see that in that interval for all values f of x is less than g of x and g of x is less than h of x. What we are saying? Minus x square is less than x square into cos 2 by x, that is again less than x square. And you can also see that if x tends to 0, minus x square is limiting towards 0. Either you go from left hand side or right hand side, you can see that the function is limiting to 0. Similarly, x square is also limiting to 0. Now, what we have introduced now, if I just remove x square cos 2 by x, you can see that, now you can see that minus x square is limiting to 0, x square is also limiting to 0, and you know that x square cos 2 by x values will be between them, then you can say that x square into cos 2 by x also limits to 0. As x tends to 0, it will have the same limit value as what minus x square and x square is having. If you expand this, this looks beautiful. You can have a look at that. So beautiful. So you can see that now, as you are moving towards 0, 0, almost equal to 0, you see that minus x square and x square cos 2 by x, all of them limit to one particular value. I hope you understood that. That's the meaning of sandwich theorem. Now let's go back. So continuing with the problem, whatever we have started, what I can say now? I can say now that, okay, I can say that minus 1 less than cos 2x by less than or equal to 1, we did that, and we have seen that as x square is limiting to 0 as x tends to 0, similarly x square and minus x square are tending. The one in between are basically the one which is sandwiched. Will have the same limit, that is nothing but equal to 0. So that's about the sandwich theorem. Now why we have to learn it? Because it's very useful in lot of examples. Not only that, we will use it in the next session when we are trying to find out that as x tends to 0, sin x by x is equal to 1. How to prove that and how we are going to use sandwich theorem in that, we will see in the next session. Thanks for your time. Bye for now.